All right. Yeah, it looks like there's a lot of stream lag today, so hopefully everyone's caught up. Um, let's see. Phantom Kel is just suggesting that we need to do the orbit. Oh, we could do the orbit by moving and using trigonometry and use sine and cosine for the move. That is true. Although I think it's actually nicer to rotate in this way because then we can deal with like if we want to have the planet itself rotate as well. We could apply that transformation and then have the planet as a whole still orbit around. But yeah, we could totally do this with sine and cosine as well for calculating the move. Let's see. Yeah, so I wanted to just mention for anyone who is in San Francisco, or I guess you don't even have to be in San Francisco, but there is a developer boot camp out here in San Francisco called TechBright Academy, which is focused on getting more women into tech. So I've been mentoring there for the past 2.5 years, and there's just a new class that is finishing. So if anyone out there is working at a place that's looking to hire more women as software developers, you can find Hackbright and follow their Twitter and see info about their new graduates and get connected with potential job applicants. Let's see. Oh yeah, I wanted to show a couple cool things I've found in the past. So we've kind of been focusing on these high-level simulation stuff for most of today. But I'm imagining this is like a project we can continue in the future. And I've actually in the past been really interested in a lot of procedural generation stuff. So here's a really cool one from a while ago. This guy was working originally on a video game that would be procedurally generated. Actually, I think some kind of RPG. And he made this algorithm for building maps for planets. And it's actually a really sophisticated algorithm. He actually has a link here. I ported this whole thing to Java a few years ago. And it's quite sophisticated. It starts by creating a random terrain map, and then it like takes some input parameters for temperature zones of the different planet, or for different temperature zones of the planet, and then applies that to create like a heat model, and then it simulates rainfall and creates oceans and all these rivers, and then based on the precipitation and the wind and the temperature models that it's generated, it applies different regions and like calculates vegetation and things like that. So this is a really cool terrain generator, or not just terrain, but it kind of generates lots of properties of different worlds. So conceivably something like this could be used within our planet simulation to make that a lot more sophisticated. Let's see. Oh yeah, I also wanted to show this JavaScript library, planetary JS, I believe this was written by Michelle Tilley, who is a developer of the Atom editor. And this is a cool little JavaScript library to make interactive globes. So this might be a cool thing to integrate with our space simulator in the future. And let's see, the last thing I wanted to share before we get back into the code is this YouTube channel, Pint in the Sky, is, I believe this is funded by a combination of the Australian government and some universities in Australia. So this is a cool little video series of some astrophysicists and astronomers talking about cool space stuff. So I will put all these links up in the video as well. So I just wanted to share a few of those things. So let's see. So where are we at here? And what else do we want to get done for today? I think probably the hardest part of what we have here is kind of making, well, I guess two things. One is getting more balanced simulations, and the other is like having ships that can move between planets. I'm not sure we're really going to be able to tackle either of those today. So maybe we can do one last thing to wrap up for today, and that can maybe be simulating a galaxy with multiple systems. Oh yeah, I did want to say one other thing. If you go and watch Simon's video of his deep space JavaScript simulations, in the video, he doesn't have this in his GitHub repo, but in the video he talks about like within the planet doing simulations with, there's an algorithm called Boids, which is kind of like flocking behavior. And there's another variation, actually the X screensaver called Swarm is similar, where it's kind of based off of insect behavior, where there's like a predator and the rest of the swarm is kind of staying together as a swarm, but following after. I guess it's, in that case, it's swarming around a target rather than having a predator. So I guess in that case, the swarm is the predator, and there's a target that's trying to escape. Let me see if I can find that real quick. Screensaver swarm. Okay, it looks like there's no demo up here. So yeah, there's a lot of stuff we could do within the planet simulation, and also just for doing the ships in space, but I think that's a bit more than we can bite off for today. So let's go ahead and create a galaxy of star systems. So we have our star system. Let's create our galaxy.elm module galaxy exposing, and we're going to have a galaxy type. We are going to have a step function also, and type alias galaxy. What do we need in here? I guess all we need is the list of systems. I guess in there we could maybe have like a property of how much dark matter is distributed in the system or something. I don't know what else, what other property a galaxy would have other than its systems. So let's stick with that for now. That means we're going to need to import star system. And then we're going to have our step function, which will take a galaxy and give back a new galaxy. Yeah, it's kind of interesting to do this simulation with immutable data structures. I guess it's back to that old concept of like every choice that you make like splits off an alternate universe, and they both continue running in parallel. So I guess that's what we're doing with immutable data. We're always creating a new galaxy at every moment. So here we're going to take our systems and replace them by mapping over. We'll make a function called update system, and we'll map over all the systems in the galaxy. And then we'll get our let statement and make our update system function. And that is not all we need. These are not just star systems. These are going to need to have properties as well. So we'll have internals again. Not super happy with that name, but it seemed to work okay. And then we're also going to have basically kind of the same stuff we had here: a distance, an orbit speed, and an orbit position. So there is a bit of duplication here. We can maybe extract some of this common stuff, but I'm not really convinced that that would give us much. Or also, the main thing I think about in deciding to extract reusable stuff is to make sure I'm really certain that the two things I'm making share code are actually the same thing, and they're not going to, that I'm not going to make them want to diverge later. I'm not totally convinced that these really share much other than some trivial similarities in their data. All right, so we've got this, and here we're going to have our system, and we'll update the internals. And we'll do that by calling star system.step on that. And we'll also basically copy this same line for the orbit position. And rather than the planet here, this is the system. Okay. So then, let's also duplicate our single system simulation and make this a, well, I guess this is still a single galaxy simulation because we could have multiple galaxies in the future, but I don't think we'll do that today. So, single galaxy is our module. All that stuff looks good. Okay, we're going to have a galaxy, so rather than importing star system, we'll import galaxy. And our initial thing will have systems. And actually, here's where maybe it would be good to start doing random generation. So let's start with one system. And it has similar stuff to this. There's one system. And again, I'm not going to worry about refactoring this just yet. So maybe we'll have one that's really close to the other. Then let's have maybe two more. And make these slightly different. All right. So that'll be good for testing this. So we still have our same tick message. And now we're going to do galaxy.step on the model.galaxy. So let's see, did I update this properly? We're going to have galaxy equals that. And this is galaxy. Lots of nested records. So yeah, I think this would be really good to start doing random generation for a lot of this stuff. View. Okay, so here's our view. So we have a way to render stars and planets I'm actually not going to make this reusable with the single system simulator either, because I think we'd probably want to render these things differently. So I think the rendering is going to diverge, so I don't want to make a reusable renderer here. But we do, okay, so there's no star in the center of our galaxy. Or there might be, but if there is, it's part of a system. So let's make our galaxies. So this is going to be list.map, and we'll render a single galaxy for each of our model.galaxy.systems. And then what will our galaxy look like? For that, we will basically render our star system. So that'll be this. And we will get from that something. Figure that out in a second. So for our galaxy, for a single galaxy, we want to basically render our system with the internals. And then we want to do this move and rotation for it. So that's the system's distance and the system's orbit position. And then we need to make this function here, system s, and we are going to map over the system's planets and grab all of those. And I guess put those in a group. All right. So let's see what this looks like. Oh, so we forgot to go to main and switch it over to our new single galaxy. So instead of single system, we'll use single galaxy everywhere. And what is wrong? Galaxy on line 22. Star system.step, this needs to be system.internals. And our planet qualifier is not in scope. Because we're still using that to create test planets. Oops, I'm getting these all out of order. And then finally, our update function doesn't match. We are updating the galaxy by calling step on the galaxy. Okay. All right, so we've got something going on here. I guess, okay, so maybe this is correct. I guess the problem here, I think, is that the orbits of the planets are on the same order of magnitude as the order of the stars themselves. So let's see. So for each planet, let's make the planets smaller. Make them little 2 dots. And oh yeah, we're also never using the star anymore. We moved that out here. So let's put the star back in. All right, and let's make the stars smaller. Okay. I guess this is maybe kind of tiny on the stream. But I do want to shrink this up so the planets will all be closer. Their star be even closer than that. There we go. So we've got some little stars. They've each got their own planets that are orbiting around them, and all those planets are also running their own economy simulations. So yeah, let's commit that. So we're simulating now a galaxy of star systems. And I guess they're all floating out there in the whiteness of space. Cool. So we've been going for about 2 hours. So I think I'm going to end for today here. And I think there's a lot of future work we could do on this. So let's make a note of that. So first of all, we want to add spaceships, of course. We also would, let's see, other good things are we want to display planets differently based on their population, tech level, etc. in the large simulations. Let's see. We could also make more sophisticated planet simulations. What else? Oh yeah, random generation of galaxies, star systems, and planets. That's a good list. I mean, we could make up a lot more stuff in terms of like adding 3D graphics to this in some way. I guess doing like random generation of the names, we could generate creatures and plants and things, and kind of move towards doing more of what No Man's Sky does, which starts to get into really hard problems of just having huge amounts of data and how do you programmatically generate a random planet without having to generate the entire planet until you zoom in and inspect it. So that's actually a really interesting problem. So that's another future thing. That's kind of a bigger project than I want to put in this to-do list. But yeah, I would, if anyone else is interested, I probably won't get back to this for a few weeks. So if anyone works on this and does some other algorithms or does the random generation or anything like that, feel free to let me know about it and we can take a look in future episodes. So yeah, thanks for tuning in. I should be able to chat for a few minutes, but I don't have a ton of time today. And next week, I will be in St. Louis at Strange Loop, and ElmConf is the day before Strange Loop. I'll be there also. If anyone else is attending, feel free to hit me up. And I will probably be back in 2 weeks with another stream, but I will let you know on Twitter. So yeah, thanks for tuning in, and I have gotten a bunch of viewer feedback and some pull requests and things from past episodes, so I think probably the next stream we'll take a look at some of that stuff that you all have been submitting. So thanks for tuning in. And if you want to watch other people, like you may have seen in the chat, Greg Zegan is going to be doing a stream soon about making an RPG maker. And also Danny, who I saw in here earlier, does a channel and a stream called Code Therapy. And he's building a game called Dual N-Back. And it's kind of actually it's a really interesting stream to watch because he is the I guess the international director of the EFF, or maybe I don't quite know the structure there, but he does a lot of cool work at the EFF and talks a bit about that on his stream quite often, and people ask some really interesting questions. So thanks, and yeah, if you're making cool stuff, be sure to let me know, and I will see you all next time. Later.